Hello, my name is Jennifer Winkleman, and I'm going to be doing the Math 117 Elementary Stats Test 1 review. Test 1 is over chapters 1, 2, and part of chapter 3. And so there's several questions on this review that are similar to the ones that your teacher might have provided you in class, or that you might have got from the STEM Alliance review. I'm going to go through some of these, so it's nice to have a video at least to look at whenever you need to. Your best bet is to try to practice these on your own and use my video for help explaining if you're lost or confused or you just don't get certain problems. It's not enough to just watch me do all this to talk about it. It's more or less you have to do it because math is all about practice. Okay, let's get started. The first one is asking to classify each of these examples as nominal, ordinal, interval, or ratio level data. Let's go through and talk about why each one of them are what they are. The first one says weight of beef cattle fed a special diet. That is ratio data. And the reason why it's ratio data is because in a ratio it has to be able to be compared to other stuff. So for instance, weight, height, things like that, you can compare them to each other. You can make them a ratio. The other thing about ratio level data is that there's a true zero. What does that mean? A true zero means that you can have no weight, you can have no height, you can have a zero there. Some of the other data here that is not possible, and so we'll talk about why that is for those, okay? So this has a true zero, that's part of why it makes ratio, things like weight, height, those kind of things. The next one is ratings of a word processing program is user-friendly. That is ordinal. What does that mean? Is that in ordinal level data, you can still rank the data, but you can rank it in terms of like good, great, fair, and poor. You can give some kind of ranking system to this, not necessarily through numbers, okay, but you can rank it in some kind of way, order it in some kind of way. For instance, another one is like coming in first, second, or third place in like a race or something. The next one says temperatures of sample automobile tires tested at 55 miles per hour for 6 minutes. That is interval level data. Now, the reason why it is interval level data has to do with temperatures. Okay? Has to do with things where there is no true zero. Meaning that, for instance, if you hit 0 degrees on a thermometer, that doesn't mean that there's nothing beneath that. There are negative numbers on the whenever you're measuring temperature, and that 0 does not mean that there's no more heat, there's no more cold. Okay, it can get colder. You see what I'm saying? So temperature is an example of interval level data, something where for instance, you have the opportunity to have something that there is no true zero in that type of data. The last but not least makes that nominal about marital status. The reason why this is nominal and not ordinal is that, for instance, with marital status, you're single, divorced, widowed, something like that. For instance, there's no way to say that one is better than the other. There's no way to rank that data as good, fair, poor, some kind of number system, first, second, third. Okay, so in this case, nominal data is stuff that cannot be put into some kind of ranking system, things like gender, any, color of crayons, something like that, okay? All right, the next one is asking for a data from a medical study. What are they, qualitative or quantitative? Well, if you're looking here, the first one is marital status, which is definitely going to be qualitative, okay? And then the next one is asking a level of calcium in the blood. That's quantitative. Quantitative are things that you can put a number on. Okay, qualitative are things that you cannot put a number on. Now, the next one says classify each as discrete or continuous. Let's talk about the difference, okay? The amount of drug injected into a rat and the number of cars stolen in a week, right? Discrete data has a 0. Discrete data has a 0, so then this can have a 0 as an answer, okay? And it's also going to be a whole number, meaning that it's not going to be 2.5. So whole number. This one is continuous because continuous has fractions and decimals. Oops, I did not. Oh, I spelled something wrong. Here we go. Okay. Okay, so this is because there's fractions and decimals. Okay. Now let's go on to the next page. Okay. It says here, determine whether each statement is true or false. So the boundaries of a value such as 6 be 5.9 to 6.1. That is false. The boundaries are always a half point below and a half point above, so we're actually looking for 5.5 to 6.5, okay? The next one says, in construction of a frequency polygon, the class limits are used for the x-axis. This is also false. It is a class midpoints, okay? So you have to know the difference between the graphs and which ones use limits, which ones use midpoints, which ones use this and that. C says, in a data set, the median will always be unique. That is true. There is always going to be one. So always one. And then the last one says, a single extremely large value can affect the median more than a mean. That is false, because if you're looking at, for instance, let's just say, very data set that has a lot of small numbers, like stuff in the teens, maybe the low 20s, and then one number in your data set is like 500, whenever you go and compute the mean, that's going to make that so much larger than it should be, when your mean should be something like, maybe 20. Okay, so you have one thing, it affects the mean, so it affects this more, and then those are, whenever you're looking at some data, those are what you refer to as outliers. Those outliers in data sets. The next one, now we have some multiple choice questions. We're going to knock them out. It says the number of ads on a 1-hour television show are what type of data? Discrete data. Okay, discrete because it has whole numbers. You can't have 2.5 advertisements on TV. All right, number 6 says data that can be classified according to color are measured on one scale. Again, that's nominal. There's no way to say this orange is better than pink, that yellow is better than the color, green, anything like that. Now, this next one says, study that involves no research or intervention is known as an observational study. If they're not intervening, they're just watching. Observational. Next one says, what is another name for the ogive? That's how you pronounce it. It is the cumulative frequency graph, because that's what the ogive has to do with. It's a cumulative frequency. That's why it goes up and it ends on an up note. The next one says, if the mode, median, mean, the distribution is positively skewed, or what they consider right skewed, okay? There's an example in your book where, it falls to the left of the mean and they cluster at the lower end. The tail is to the right. So an example, quick one real quick, is something like this. This is kind of what it looks like. And so then this would be the mode. This one would be the median. And this one would be like the mean. So then that's kind of how they cluster, okay? The last one says, when data are categorized as places of residence, the most appropriate measure of central tendency is what? Well, here's the thing, rural, suburban, urban. There's no way to rank which one is better than the other. There's no way to really put a number on that. So things like median, which one's in the middle, that's not going to work. The mean's not going to help. Mid-range is not going to help. It's going to be mode. Mode is going to tell us the number, the most popular answer. So the most popular answer is going to be the best way to figure out, some parts of your data using central tendency, okay? Alright, let's do this next example. Now, this next example is a questionnaire on housing arrangements showed this information, construct a frequency distribution. So, here's what you do. Your classes are your numbers here, your that's your numbers, your H, A, M, and C. So I'm just going to write them here, A, C, H, and M. And then the frequency is whenever you go through and you count them out. So you're sitting here, you go, okay, well, I got 1H, 2H, 3H, you got 4H, 10, 5H, and 6H. And so the tally is that 1, 2, 3, 4, 5, 6. Okay, and the frequency is also the same number. Now that I've done one tally, I'm not going to do the rest of the tallies. But going through this, the frequency is 5, 8, 6, and 6. How do you find the percent? Well, the total here is 25, so the total is 25. I take the frequency number divided by the total, 5 out of 25, and I make that a decimal, 0.20. The next one would be 8 out of 25, which is 0.32, and then 6 out of 25, which is 0.24, and the same thing for the last one, 0.24. Okay, this number, all these here, all these decimals need to add up to 1. That's how you know you did that correctly. That's all they wanted for that part of the problem. The next part says, if you were to construct a pie graph for the data, what will be the size of the angle that represents people living in condominiums? So we're talking about C. Well, the formula for this, okay, is going to be what you're going to have your frequency out of your total, that's n, times 360. Why 360? Because we're talking about a pie graph. What's a pie graph? A circle. Okay, so my frequency is 8 out of 25 times 360. Punch that into a calculator, and I end up with a decimal, okay? And I need to round it. We like whole numbers in this case. So I get 115 degrees for my answer. You get something a little bit over, but you want to round it to that. I'm going to pause on this one and start on with number 12. Okay?